Hello, engineers. Welcome back to our series, Mastering the CEBoard Exam. Problem na ito ay sagutan natin another situation last April 2025 in PSAD. A hollow circular pole is bent as shown. The outer diameter is 110 millimeters and the pole thickness is 8 mm. The pole is subjected to a force P equal to 12 kilonewtons. Ito daw pole na to ay binend with an angle of 30 degrees directed to this point C. And yung cross-section ng pole, we can start illustrating that. It is 110 mm, yung outer diameter. So hollow siya, no? Circular or hollow circular pole. Like that. And eto, the dimension here, this is 110. And the thickness, 8 mm. And eto is also 8 mm. So we have an inner diameter here, that is inner diameter 110 mm minus dalawang 8 mm. This is equal to 94 millimeters. All right, let us proceed to question number 1. Determine the axial stress at C at this point. Now, let us recap muna. What do we mean when we say axial stress? When we say axial stress, that is simply the stress caused by a normal force or a force perpendicular to the cross-sectional area. So you can say that axial stress is simply the normal force all over the area. Here at point C, this is not vertical or horizontal yung cross-section. The cross-section is inclined. Therefore, the normal stress or the normal force acting on point C would look like this. Ito yung N. We need to solve for N to solve for the axial stress. Now, to solve for N, let us first isolate this section. Ito. Let us redraw. Okay. And meron tayong 30 degrees na angle dito. This is parallel yung surface ng section C or point C. And this one. This is 30 degrees. Ito is 0.8. This is also 0.8. This is your normal force. Perpendicular siya sa cross-section or sa section C. When you say perpendicular, this forms a 90-degree angle. Okay. And before we forget, we have here your force P. This force P is equal to 12 kilonewtons. And this is your N. Okay. Now, what are the other forces present at point C? We also have your shear force. The shear force is parallel to the cross section. So this is V, and at point C, this will also carry, since nagkatayo dito, this will carry the vertical force P. Okay? So magkakaroon dito ng reaction, opposite reaction. So equal sila ng 12 kilonewton, but opposite lang in direction. So this is 12 kilonewtons. And let me erase this one. Okay. Now, our goal here is to solve for N. Kasi once we have solved for N, we can now solve for the axial stress. How do we solve for N? Let us first designate the possible angles here of the forces. So if this V is parallel to the cross section or the section C here, meaning it forms a 30-degree angle. The same parallel kasi ito, di ba? So 30-degree angle with respect to the horizontal. As you can notice, our 12 kilonewton is a vertical force. If this is a vertical force, so it will form a perpendicular angle with respect to the horizontal. So ito, 90 degrees ito. Meaning, if this is 30 degrees, the remaining angle here is 60 degrees. Okay, next, let us solve for this angle. Let us call this one alpha. To solve for alpha, let us consider this straight line. Ito, this straight line here. Diba, for a straight line, the total angle of a straight line is 180 degrees. We can solve na for alpha using that concept. 90 degrees, eto, 90 degrees plus alpha plus 60 degrees, that is equal to 180 degrees. Solving for alpha, that is 30 degrees. Okay, meron na tayong alpha. Let us form a right triangle. So, perpendicular ito kasi right triangle. Using N and etong vertical force na reaction. Okay, isolating this right triangle, we will have like this. This is 12 kilonewtons. This is your N. And if this is the perpendicular angle, eto yung alpha na 30 degrees. So with this, we can now solve for N. This is adjacent side, hypotenuse. So we can use the trigonometric function na cosine. So cosine, 30 degrees, that is equal to the adjacent side all over the hypotenuse. Solving for N, N is equal to 12 cosine 30 degrees, which is magkano? 10.39 kilonewtons. We can now solve for the axial stress, that is N all over A. But first, what is our A? Our A, that is simply pi over 4. This is a hollow circular section. So d outer squared minus d inner squared. That is why earlier we have solved for yung d inner, the 94 mm. Okay, so let us solve for your axial stress. That is sigma. Okay, 10.39. We multiply this by 1,000 para magiging newtons. Then pi over 4. The d outer, that is 110 squared minus 94 squared. With this, we can now solve for the axial stress, that is 4.05 MPa. And base the choices, that is letter B. Okay? This is for number 1. Let us proceed to number 2. Let me copy ito. So number 2, we want to solve for the shear stress at C. Shear stress is simply tau, that is the shear force all over the area of the cross section by which the force is parallel to. So same lang, that is A. Right? Now, to solve for V, we can solve for V using this triangle. Using this triangle. This is perpendicular ulit. Perpendicular ito, and this is 60 degrees. So let us rewrite or redraw. We have here 12 kilonewtons. And ito yung V. Ito siya, nakaparallel siya, di ba? Ito. So this is your V and 60 degrees. Okay, we can solve for V. V is simply the same. Oh, cosine ulit yung gagamitin kasi nasa adjacent side yung V. So 12 cosine 60 degrees. V is equal to 6 kilonewtons. With this, we can now solve for the shear stress. Tau, 6 kilonewton is 6,000 newton all over pi over 4, yung same na cross-sectional area, 110 squared minus 94 squared. Solving for this is equal to 2.34 megapascals. That is letter A. All right. So this is the answer for number 2. Let us proceed to number 3. Flexural stress naman at C. Let me copy again. This time, since flexural stress, let me erase this one. What do we mean by flexural stress? Flexural stress is simply your bending stress, FB. FB, that is MC all over I. Okay. So we need the moment at point C. Question. So how do we solve for moment? We have here your vertical force going downwards. If we take moment about C, it will rotate in this manner, clockwise. So ganito siya. This is MC. Now, what will be our moment arm? Remember, this is a vertical force. Our moment arm must be the perpendicular distance or yung distance na nagpo-form sa 90-degree angle. So, if this is the vertical force, yung distance should be horizontal. So, eto siya. This is X. Okay, let me, so pagpasensyahan nyo na, no? Yung drawing. So, hindi siya up to scale. But, yeah, this is your moment arm. So, the moment at C, like, let me make this one big letter. MC. Yung small letter na C ito, this is the distance to the neutral axis from the outermost fiber. So, this is MC, signifying yung point C. Okay, big letter C ito. Okay, so, moment at C, that is 12 times X. Now, how do we solve for X? Okay, we solve for X, this is 0.8 meters, meaning X must be less than 0.8 meters. Now, we need this distance. As you can notice, this hypotenuse, if we consider this triangle, this right triangle here, this is the hypotenuse, this is the adjacent side, meaning the distance here is simply 0.8 cosine 30. Okay? Now, with this, we can say that 0.8 cosine 30 plus x is equal to 0.8. Solving for x, that is 0.8 minus 0.8 cosine 30. X would be equal to 0.107 or 107. Okay. Now we can solve for MC. That is 12 multiplied by 12 kilonewtons multiplied by 0.1072 meters. This is equal to 1.286 kilonewton meter. Right? We now have the value of your moment at C. We can now solve for FB. So in small letter C, again, that is the distance from the neutral axis to the extreme fiber of the cross section. So if this is a circular section, this is the neutral axis will be at the middle. The distance from the neutral axis to the extreme fiber, either at the top or at the bottom, that is simply ito. This is the outer diameter divided by 2, or 110 over 2, which is 55 mm. Okay, so this is your C. This is the value of your C. How about your I? Your I is simply the moment of inertia of a hollow circular section. So the moment of inertia, that is pi over 64, diba? For circular, that is pi over 64. Then d outer raised to 4 minus d inner raised to 4. Okay, we will just direct this in the equation. So let us solve for FB. FB is equal to M. Moment at C, that is 1.286 kilonewton meter. We will change this into Newton mm. So we multiply 1 million. So that is 1 times 10 raised to 6. In order for this to be converted to Newton mm, then you see that is 55 millimeters all over the moment of inertia, pi over 64, d outer raised to 4, that is 110 raised to 4, minus d inner, 94, raised to 4. Okay? Solving for this, the answer will be 21.09 megapascals. And that is letter C. Right? So that this is our solution for this situation last April 2025. So thank you everyone for watching, and like and subscribe for more videos and tutorials about the CEBoard exam.